So we're going to let the good times roll here and keep doing more derivatives with the chain rule. Because practice makes permanent. Only perfect's practice makes perfect. So we want to find the derivative. Now we have trig functions here. But the thing about trig functions is they work just the same as anything else. You just have to write them just follow the process. So what we're going to do is we're going to say, okay, my inside piece here is 8x. My outside piece, whatever is left, is cosine of that glob, so that's cosine of x. Now I need to find f prime, and that's negative sine of x. And need to find f prime at g, so that's negative sine of 8x. Okay? So then from there, I need to find g prime, and that's 8. So my answer is these multiplied together, negative 8 sine 8x. Simple enough, right? Let's do one that's a little more complicated, but not much more complicated. 2 sine 4 pi x. So we'll take that inside piece. We'll say that g of x is 4 pi x. And then what's left over? Well, 2 sine of something, so it's sine of x. So we'll take f prime here, and that's 2 cosine of x. And then we'll take f prime at g. So that's 2 cosine, instead of cosine of x, it's cosine of 4 pi x. Alright, now we need to get g prime. That's 4 pi, right? Just drop the x off there. And so we multiply these together and we get 8 pi cosine 4 pi x. See, you just keep on keeping on. Now, this one's a little more tricky. So what we're going to do is we're going to say g of x. So what's inside here? Well, what's inside is pi x to the 8th. Right? Because that's what's inside there. So what's left over? Well, what's left over is sine of just x, right? Sine, because that whole glob got taken out, so what's left is sine of x. Now, when we do f prime of x, we get cosine of x. When we do f prime at g, we do cosine of pi x to the 8th. Okay. But now we need g prime of x. G prime, pi x to the 8th. Uh-oh. So there's a couple ways to do this, and you might have thought about one of them already, which is you could distribute the 8 out, and you'd have pi to the 8, x to the 8th. And that'd be a perfectly fine way to do that. But I want to do it a slightly different way. So let's take this as a function. If this was my function, well, I'm going to break this into a subchain rule. I'm going to break this into a subchain rule and say, okay, my inside function here is pi x. Whatever's left, my outside function is x to the 8th. So f prime of x is 8x to the 7th. So f prime at g is 8 pi x to the 7th. Well, I'm definitely bad at numbering, aren't I? So then my next piece is the g prime, which is just pi. So I end up with 8 pi x to the 7th, which by the way is 8 pi to the 8 x to the 7th, which is what you would have gotten if you had distributed that out as pi to the 8th, x to the 8th. You know, the power rule would have brought down the 8, subtracted 1 from the power. So we would have gotten the same thing. So I know it's a lot of work, but it's just showing you that you can break these things down into chain rules. So that tells me that this is 8 pi x to the 7th. So my final answer is this times that. So 8 pi x to the 7th cosine pi x to the 8th. Does that feel satisfying? Maybe it should, maybe it shouldn't, I don't know. But this is how you apply the chain rule. You just follow the algorithm, it works out. Why it works is a little more tricky, but trust me for now, as you move on, we'll get more into it.